Hi, my name is Dr. Jonah Schulman. This is going to be the Math for Teachers course. I've broken this down into two parts. There's going to be an algebra part and a geometry part, but basically most of the information is going to be the same. I will be going over the tests that you need to pass in order to become an elementary school teacher, specifically the math portions of that exam. And you're going to get some choices to see like how you'd be a teacher and get to create materials and decide like what you'd like to do best on your journey. Now, to be an elementary school teacher here in New Mexico, you need to pass the Praxis Elementary exam. Now, other states use the Praxis Core, and if making these videos go well, I'll do the core too, so you have more options to look through. But everything that I'm going to do, you're going to have access to, which is great. I've created something that I call the Training Handbook for Effective Math Educators, or theme. You've got access to all of that. That's going to be where most of the projects come in. I'm making quizzes and tests to just go over the math content. But basically, the course is broken down to three parts because that's what you need to pass in order to become an elementary school teacher. So one part is curriculum, one part's instruction, and one part's assessment. So I thought the best way to structure this course would be based on the exam you have to pass in order to become that elementary school teacher. If you need more information or if you'd like more stuff, just let me know. I'm going to share my screen. This first one, I'm going to go over the exam and you're going to get a chance to try a pretest. And I'll also, I don't know if I'm going to see if I can import the pretest. Otherwise, you just pause the video and you try the pretest yourself. Then I'm going to go over all the answers. So I'm going to do two of these pretests. There's like five practice exams that I have access to. And I think I'm going to be going over all of that information. And then your test is going to be based off of how I generate my own questions based off of everything we have. I hope that wasn't too much of a long introduction, but again, this is Dr. Jonah Schulman. You refer to me as Jonah. I've taught math for over a decade now, mostly in high schools, but I've trained a lot of elementary school teachers. And I hope that all this information that I'm going to share with you will be useful. Feel free to give me feedback along the way. You'll have my email and access to everything. And just feel free to reach out. Some of the stuff might be hard, but if it's hard, guess what? That means we're learning. I might make mistakes too. And guess what? All the information it's if it's hard, if it's not too hard, you're not learning. That's that idea of the more we struggle, the more we learn. So hopefully that'll be good. And let's get in the mind of our students because they'll definitely be struggling. So why not? We'll probably struggle as well. So I'm going to share my screen and we're going to jump into it. So the first thing I want to show you is this notes page. Now here I'm going to be writing by hand everything that we need to do. Everybody has access to this. You can go through my FCC and go to your notes page and you can click this link. I'll also have this link in the course to have access to everything. So you will get access to the link and this will bring you here. Notice it says Math for Teachers 1, which is the algebra right here. Math for Teachers 2, that's geometry. The only difference is that I have the algebra parts here. Those are these A's, algebra thinking and linear equations. But I wanted you to be ready for everything. So that's why we're going to go over all the proportions, numbers in operation, as well as the data. But most of the bulk of it will be here in algebra. For geometry, notice that all the notes are pretty much the same, except instead of those algebra parts in the middle, we have geometry parts in the middle. But you will still get access to proportions, like numbers and operations, data, which I think is important, and just everything you need to do well on this exam. So that's a little bit about where I'm going to be writing into this. You'll have access. Notice that I'm going to do two pre-tests before we get started, and then we're going to jump into it. The other thing that's in here is this handbook. Well, yeah, I'll go into the handbook. So the handbook, this is something I created, and you have access to it. So the handbook is pretty much every possible thing I think you need to be a good math educator. So let's look at it this way. We have action research, art enhancement and integration, things about bullying and harassment, building your classroom, how to create your curriculum, stuff about equity, gamification and game-based learning, lesson planning, stuff about your licensure, metacognition, using media and social media protocols. And they're all like really good assessments. So let's go to just lesson planning, which I think is really important, just to give you a little overview of what these look like. So these are access to lesson plans. These are all the parts that lesson plans can have and some information about it. And then you get to rate a bunch of lesson plans. So I have like between sixth grade standards and up. But basically, these are 1, 2, 3, 4, 5, 6, 7 types of lesson plans you can look at. Then you get to, guess what? Rate the lesson plans and decide how you use the values, why you pick these values for it. And then you get to write which one you chose the best. And for each of them, you can modify, use them as your own. And then you get to create a lesson plan. You either use these templates that I have or just your own. Created a lesson plan, a videotape you doing the lesson, and reflecting on it. And these are the principles as it relates to the national standards for mathematics. Now, if you want to see how good you did on this one, or let's say a different one, in your notes, there's a rubric, so you can learn how to grade yourself for all of these things. And the rubric for lesson planning looks like so. So we'll probably do a couple of these. I'll decide exactly which ones that we're going to do. But this is pretty much how I'd be grading it. And you could also grade yourself. I like rubrics a lot. Why? Because it keeps me from being biased. Because no matter what, you're going to have students you like better than others. It's just natural. But if you cover up the names and you use a rubric, it'll be a lot easier for you to grade it. And so that's just a little bit of stuff that's in here. But you have access to everything that's in the theme, which I think will be really useful. Now, again, this is the notes link to get to this page. It says math for teachers. There's 1 and 2, but basically they're going to have all the same information. I'll copy and paste all the ones that kind of match in here. So let's go into this introduction. That's that note. Now, if I click this little bookshelf right here, it all moves and it's easier to read. And the most important thing is information about the exam. And we'll take it from here. So this is your test. This is the one you need to pass in order to become an elementary school teacher. It's been around for a while. I took the Praxis Core, which is tough. And then I took the specific math for secondary, which went all the way up to Calculus 2, which was crazy tough. It's the national exam, so it goes for everybody. Certain states have different cutoffs, but that's how that test is created. On top of this exam, every state has stuff a little bit different. Like New York uses their own test, California uses their own test, and Florida are some states that don't use the Praxis. However, if you pass the Praxis, you can transfer the score into that state as long as you already have your license. And if you want to learn more about licensures and certifications, you could just go into that piece. But the course is going to be built off this exam because I want you to be able to pass it. So let's get into your test. This is information about it. What should you do? How to take it? What states require it? And the cutoff scores. They're at testing centers. So let's learn about the tests, and then we'll do some practice ones. And again, if I make mistakes, that's okay. But I want you to try it yourself just to see how you would do on the math portion. So we know exactly where to focus on and where to study. So I think it'll be a good thing for you to try it first. So here's your test. It is 120 questions. It will take you an hour and a half to finish, 130 minutes. So sorry, a little bit over 2 hours. Sorry about that. Notice that mathematics is the second part. It's this little part of the pie. It's cut into 1, 2, 3, 4, 5 pieces, but it isn't actually 1/5 of it. It's a little bit more than a quarter of your exam. You see how this 2 is a little bit bigger than a quarter. And I'll do a lot of stuff with visualizing and help us visualize what we need to do and what this means. So this mathematics, we have 31 questions and it is 26%. Now, just so we can get a little bit, every math symbol that we're going to look at has a name and has a place. So this is a percent symbol, but most things in math actually tell us what we need to do, which is really useful. This actually is the word percent or percent. So per, think miles per hour, points per game, words per minute. The per actually in mathematics means to divide. That's what that means. And that's why the symbol itself starts with this. That's where the symbol comes from, okay? That's why the symbol itself starts right there. Starts right here with one of these. It means to divide. Now, cent, you can think about as how many cents in a dollar. How many legs on a centipede. That's my happy centipede. Or how many years in a century. All of that should tell you exactly what we need for this part. So the cent actually means 100. So per means to divide, and the cent means 100. That's why the symbol itself looks like this. So if I have this 26%, it really means the same thing as 26 over 100. Every time you see this percent symbol, it just means to divide by 100. In mathematics, we can have a fraction or fraction, which means fractus or broken. It means broken, and we have a top over a bottom. So I have 26 over 100. So basically, it is another division symbol. This stands for the numerator, and that stands for the denominator. And notice that you can put the two circles right here. So when you're working with fractions, it's really just division. And fraction comes from the word fractus, which just means broken. So we can simplify this. We can divide it by 2 because they're both even numbers first, and that gives us what? 13 over 50. Now, and to divide everything, so this is the percentage, and this is the simplified fraction. But if you just want to divide it, you always take the what? You take the big number, and that gets to live inside the house for division. So I basically push this. I have a 26 here, and I have a 100 here. Now, I can't put 100 into a 2. It's too big. I can't put 100 into a 26. The 100's still too big, so that's where I put this decimal. The decimal allows me to put a what? A 0 here. Now, 100 goes into 260 2 times. So that is 200. If I subtract it, I'm left with 60. Now, every time I have the dot, it lets me put as many zeros as I want after it. And 100 goes into 600 6 times. So 26% is the same thing as 26 over 100, 13 over 50, or 0.26. This is what's called a decimal or decimal. Decimals are just it's like a part out of a whole. This is your 10th place. This is your 100th place. And we actually use a base 10 system. That base 10 actually helps us a ton. It helps us really think about how we break things into parts. So this is our whole number 1, and this is our tens place. And think about for a second, why do you think we use base 10? It's the same reason why Mayans use base 20. So Mayans don't stop at 10. It's like single dots until they get to 20. It's kind of the same reason why we use 10. The best thing to think about is how do you first learn to count? You use your fingers. How many do I have? 10. And that's why I have a base 10. The Mayans, they might have been 2 times smarter than us because they used base 20. Shoes weren't very popular for the Mayans, so they counted with their fingers and their toes. So basically, this 0.26 is the same thing as 26% or 26 over 100. Now, 13 over 50 should be the same thing. So let's actually see that. Can I put a 50 into a 1? No, doesn't fit. A 15 and a 13 doesn't fit, so I have a decimal here. Well, 50 goes into 130 two times. 2 times 0 is 0. 2 times 5 is 10. And I have what left over? 3, 0. Now I have the decimal, so I can bring down as many as I want. And 50 times what gives us 300? Well, we can think about it as 5 times what gives us 30. The correct answer is 6. Look, they match. So in mathematics, they'll always match. They'll always be the same. So 13 over 50, 13/50ths, 26 over 100, 26% or 0.26. Another way you can think about it for that 26% is that since we're dividing by 2 zeros, you just have to take this and move it over once, twice, 1, 2 decimal places to account for the zeros, and that will automatically give you that 0.26. It's kind of a faster way, but this is the reason why it works. All right, let's get back into the test. I know we didn't get very far, but 31 out of 120 questions should look like this amount of the pizza pie. Sorry, got lots of stuff open. So we have 31 over. And this is how probability works, and we're going to go into this a lot. 31 over 120. Okay. For probability or for percentages, it's always just what you want to get out of the total. I know it's not a complicated formula. It's just something that I made up to help people out. So 31 out of 120. Now, we're just going to move it over just like this. The 31 goes here. The 120 goes here. Can 120 go into 3? Nope. Can it go into 31? Nope. So we need a decimal. So 120 times what goes into 310? We can say it goes in twice. 120 times 2. 2 times 0 is 0. 2 times 2 is 4. And then 2 times 1 is 2. So I have 240. We subtract it. 0 minus 0 is 0. 1 can't minus 4, so we actually have to cross this out. 11 minus 4 is 7. And 2 minus 2 is 0. So I have 70 here. I have to bring down another 0. Now, it's not 12. So this is what I'm saying by crossing out the zeros. I literally have 700 over 120 right now. The zeros can cancel. So I'm just looking at how many times does 12 go into 70. 12 times 1 is 12. Not big enough. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. 12 times 5 is 5 times 2 is 0. Carry the 1, 60. And 12 times 6 is 72. See, I'm too big here. So it's actually 0.25, which gives me 600. And I have 100 left over. So I bring down another 0. So there's a remainder here. We can keep going. Let's go one more decimal place. So we know 12 times 6 is 70. 12 times 7 is, well, if you don't know, 7 times 2 is 14. Carry the 1. 7 times 1 is 7, 84. We're not there yet. 12 times 8. 8 times 2 is 16. Carry the 1, 96. So here we go. It's going to be 12 times 8. So we have 960. Put the extra 0. And we're left with just a 40 down here. There's still a remainder, but we're not going to keep going here. We're left with 0.256. And this, sorry, 0.258. I apologize. Which is what they rounded. Here, I'll erase that. Which they rounded to be 26%. Now, this 0.258, nothing too crazy about it. they're just rounding it up, and that symbol that I just drew, this means to approximate. Doesn't mean that they're equal, it just means we're approximating right now. I know, nothing too crazy, but that's where it comes from. All right, let's keep going. At least now we know how much of the test is math that we need to finish, and I thought I'd give you a little bit of math to start. I always look at pies. I always try to draw things no matter what it is. So, one more thing before we get into the parts of the test. When they say 26%, or in our case, we know 25.8%, always try to help your students create a visual, okay? The visual is going to help them a ton. So I don't care if you do this in boxes. We want to make 26 out of 100. The first thing I'm always going to go to is to round this. I will always have my students round and estimate so they get a sense of what the number actually means. And 25 over 100 is literally just 1/4. We can divide top and bottom by 25, and that's how I got the 1/4. So 25% or 1/4 is what I'd have my students draw. So I'd either say, what does 1/4 look like to you? Some students might do this, cut a piece of paper in a 4 and color in 1/4. Some students might do a circle. Some students might make a square instead of that rectangle piece that I have. The best thing you can do for your students is have them try to visualize what these values are. The more they can visualize what the values are, the better they're going to be. The better they're going to be able to do this. So when they say 26%, they should be able to generate some sort of image that looks close. If you want them to be exact, well, 26% we know is 13 out of 50. How would I draw 13 out of 50? I'd probably create a box. 1, 2, 3, 4, cut into 5. 1, 2, 3, 4, 5. And that's going to be a whole piece with a little bit left over. And that's how I'd have them represent 26 out of 100. But it's up to you, you know? Every person visualize things differently. The best thing you could do for your students is have them try to create mental representations or constructions of what they're doing. We're going to talk about constructions too, but I just thought this would be a great way to start us thinking about it. All right, the other things on your tests are reading, language, arts. I'm not going to go over science. I'm not going to show social studies, art, music, and physical education. Now, part of this course, I'm going to show you how you can connect all of them to math, because the best thing about numbers is you can make them whatever you want them to be. And if you make them whatever you want them to be, guess what? You're going to be good. You're going to be really good to go. So more information about the exam, the content topics. This is what we really need to see. So here's your content topics for mathematics. We have curriculum. That's why, as you can see in here, the first pieces that we're looking at are curriculum information. And the curriculum stuff in the test is basically just how to make a sequence. I'll show you how to do that, how to sequence lessons, how to address common misconceptions, which is really important, and making connections with math and other disciplines. So I'm going to show you how to do that, and you're going to get to pick one of these things to try yourself, which will be really nice. That'll be the end of the first part of the course. But you have access to everything. Now, B is instruction. This is where we're going to get into like the content, the real content, the nitty gritty. So basically, for instruction, it says how to design instruction, incorporate the standards of mathematical practices to meet diverse needs, and select developmentally appropriate instructional methods, strategies, manipulative models to support learning in these areas. Now, if you don't know what the areas are, you're going to struggle. So this is going to be the bulk of what the course is, me teaching you how to do stuff, and then you getting to decide how you'd actually teach it. Using the lesson plans, the lesson plan assessment, or whatever assessments I think like gamification or project-based learning. We're gonna have to pick those. So what does instruction have? We've got numbers and operations. So what are the different types of numbers? We've got ways to add, subtract, multiply, and divide. So models for doing that. Operations, I did division, I think already, but we'll go through that. Mental math strategies, other ways of saying division, fractions and division, and modeling. So there's a lot here. There's a lot to go over. The next thing is numbers and proportional relationships. So what's a proportion? What's a ratio? It's really important to know the difference. We'll go over that. Then we've got number theory, which is prime numbers, composite numbers, factors, and multiples. Now we got algebraic thinking, equations and formulas. This is so 4 and 5 is going to be the most that I'm going to cover. So I'm going to show you tons of ways to teach algebra because this part of the course is the algebra course, or if you're in the geometry, I'm going to teach you tons of ways to do geometry, which is 1, 2, and 3-dimensional figures. I'll show you everything, how to do nets, every possible way to do area, perimeter, volume, surface area, whatever you need. The coordinate plane, I'll teach you where it comes from. So I guess I didn't mention this, but most of the math I've done is like how to teach math better. So if your students don't know where this stuff comes from, like you know how I broke down the percent symbol into the word, like or like mean, median, mode, or coordinate plane, right? Like if you don't teach your students about who created it, it's called a Cartesian coordinate plane. So it was made by Descartes, which is really cool. And the reason why he made it was he was trying to set up fly traps in his on his ceiling to collect all the flies because he was very dirty and he liked to stay in bed real late. And that's how he created the X, Y, and the Z axis. And for every single thing that we do or what you show your students, the goal should probably be to humanize it. How can we make the students see that the mathematics came from somebody and it was useful? So for each one of these, I'll try to show you who came from, why it's useful to really be able to share that with your students. And finally, measurement. Conversion's great. To help students with this, I always do songs. They always convert their songs, their favorite songs, into different beats per minute, beats per second, beats per hour. It also helps your students see how old they were if they measure their life not in years but in seconds. All those kinds of lessons are really fun. I'll show you how to do it. And then finally, data. Data is probably the biggest thing to help your students with because they're going to need it throughout whatever career or path they choose. It's the best way to understand numbers. So data is really important. So I'm going to spend a lot of time showing you measure the center, which is mean, median, mode, and statistics and probability. I'll show you how to histogram, bar graphs, whatever you need, as well as probability. 11, I might take the most time with because no matter how old students get, I feel like they really struggle with probability. And it's usually the one that's left out because teachers run out of time throughout their learning career. So I'm going to show you really good ways to help students learn probability through experiments and things like that. Finally, the last piece will be assessment. And basically the difference between formative and summative assessment, misconceptions that occur in teaching, which happen all the time. You're going to see common mistakes and you're going to have to figure out the best way to like teach them or reteach them. Whether that is showing students possible mistakes, whether that is planning for possible mistakes, or whatever that falls under. So I think all that's important. And finally, use appropriate assessment methods. So whether it's traditional, standardized to evaluate student learning. Here, I'll probably go into stuff like project-based learning. I think I'm going to have everybody either try project-based learning or something along those lines. I think this one would probably be really good for us to finish the course with. So I think this might be like the last little project we will do is the project-based learning one. Why? Because you get to look through 1, 2, 3, 4, 5, 6, 7, 8 different types of projects that I've done in my courses and classes. You get to read about them. You get to see, we got the song lyrics one there and a bunch of other types of projects. And and you get to assess the value of it, and then you get to create your own. So I'm pretty sure this is how we're going to end the class. I think I'll give you a choice between project-based learning and game-based learning. So I'm pretty sure that's how the course is going to end. All right. So this is the point in this first video where I was planning to do the pretest. So what would I like everybody to do? So I want everybody to click on this link. It's in there. And I want you all to go to the sample test question. So this is page 21. So I want everybody to go to page 21, and I want you all to try numbers 10 through, how many are there? 17. So you got 8 problems to do, 10 through 17. So I want everybody to pause and just take a second and see how you would do problems 10 through 17. Now, I know you might have to skip some, but I'm going to go through each of these and I'll explain how to do them. And after each problem, I will check the answers to see if we're right. I think it'll be a really good way to see how much you know versus how much you don't know and where to focus your best study. So let's say you really don't know how to do the algebra ones, really focus on the algebra. Let's say you have no idea how probability works. That'll be the one that you should study the most. I think this is all about the ideas of metacognition. And metacognitive learning is learning about your learning or how you work the best. The 2 things that I've done that are probably the best in metacognition and that have been like the most downloaded things I've ever done or created. One is this reflection guide where you let students kind of reflect on their exam. What was their score? Were they happy with it? What do they need help with? How are they going to get the help? What are they confident about? And what would they like to learn for the rest of the year? And this is every possible thing that I've done in the course. So did the guided notes help or not? Were the quizzes and exit tickets helpful or not? Was this rim making project? Was this? Oh, this was circle. So they got to design the rims for their car. Was the history review. So I showed them all the stuff about history, about circles. And we watched a video about like pi versus tau that they liked. And every week I always do math vocabulary with them and they get to decide which was helpful. How did I get students to fill this out? They did it. They got to complete their work for what? Half credits on everything. So that's the idea of giving students a chance to think about their work and why is it useful for you? You get to see what's working for your students. Not everything's going to work for everybody. Throughout this time, email me, tell me what's working about the videos, tell me what's not working about the videos. I'm more than happy to ship things around. You let me know what the most helpful stuff is. The other metacognitive thing that my students have found really helpful is a score chart. This is when I had to build an ACT math course for my students. They get to draw the line for their ideal score, what they wanted, and then every practice test along the way, they got to fill this in to see how close they got for their score. The back just had test taking tips, but this is every day my students would look at this and see where they were. And I also had a really big one of these at the back of my wall, and they had their name with a little post-it, and they got to move it based on their highest score. So knowing your scores as you go throughout something, especially like passing a test like this, is very important. So what would I like you to do? I want you to pause this video, and I want you to try questions 10 through 17, and then I'll see if I can get them right as well. All right. So I hope you had a nice attempt at these. I'm going to start with number 10. I'm going to shut this, and I'm going to read you these questions, and I would show you how I would do them. Let's see if I get them all right. I haven't seen these yet, so let's see what happens. So I'm going to pull this to the side. Here's number 10 to start with. A teacher wants to teach a lesson on writing equations to solve word problems. Which of the following should the students have learned before the lesson? Okay, so this is basically, you want your student to know about writing word problems. Now, word problems are really tough for students because they get confused and they don't know what to do first. So you should always be giving them strategies like underlining, and circling operations. Another strategy is drawing pictures. My favorite one is estimation. So these are just some strategies you can have for your student for because writing word problems are really hard for kids. Okay, it's hard for everybody. Um, so this is on writing equations to solve word problems. So we're writing the equation, sorry. So we are we're writing an equation to solve a word problem. All right. Well, we'll see what the choices are. Writing an equation for word problems. I like underlining and circling the operations. I like drawing a picture. I like estimation. So what do we have? How to use variables to represent unknown quantities. That's definitely something good, but we want to know what should they have learned first. So we have the choices A, B, C, and D. I'm going to probably use elimination. How to add and subtract polynomials. Um, that has nothing to do with writing the equation for word problems. It's probably they just want to know what happens in the sequence. So I'm not going with D. How to solve variables, how to solve systems of equation with two variables. This also sounds too hard. C also sounds too hard. Why does C sound too hard? C sounds too hard because I'd probably start with just one variable before jumping to two variables. So that's why C I don't like. How to graph linear equations. Okay, graphing linear equations. We just want to write the equation. We could always turn everything into a two-dimensional graph, so I think that's too hard. So I'm going with A. How to use variables to represent unknown quantities. So we're going to give everything an X or a Y, solve it. So let's see if 10 was A. Mathematics, 10 is A. Sweet. So the question tests your knowledge on how to sequence lessons within a curriculum is to identify unknown quantities and then represent them with variables. Once that, okay, cool. So we were right for the first one. That looks nice. Hopefully you got it right. If you didn't, that's okay. It's the first one. Let's look at 11. Let's see what 11 has in store for us. Which of the following word problems and other word problems is most important when first introducing the relationship between fractions and division? Okay, so which word problem should we do? So this is another sequencing. We're trying to find here the easiest beginner step. Because that's what we want to do first, not last. All right, so we have A, B, C, and D. Let's see what we got in store for us. 3 children are sharing 2 pizzas. In order for each child to get the same amount, how much pizza can each one have? So we have 3 children. 3 children sharing 2 pizzas. Oh, sorry. So we have 2 pizzas. We have 3 students sharing them. So can we cut this into 1, 2, 3 amounts? To me, this sounds like the easiest one to do. I like A already, but I'm going to look at the rest of them. Okay, so B already has a mixed number. That's something I would not do first. So Mario has 1 3/4 hours to finish 3 homework assignments. If he divides time evenly, how much time can he spend on each? So we still have this to break into 3 parts, right? Right. So here we have 2 and 3, right? Sharing 2 pizzas. So we have 3 children sharing 2 pizzas. How much did they get each? 3 children sharing 2 pizzas. How much do they get each? I like this. They all get, you know, 2/3 of a pizza because because if we put them together, well, I'll go to that one in a second. I think that's the answer, but I got it confused on how to do it. I'll show you why this one doesn't work. Let's look at this one. So in order to change this mixed number into a fraction, the first thing you have to do is you have to multiply the bottom and add the top. So 1 times 4 is 4 plus 3 is 7. So this is 7/4. So Mario has 7/4 to finish 3 homework assignments. If he divides his time evenly, so we have 7/4 hours. How much time does he have to finish in 3? 1, 2, 3. So basically I have to take 7/4 and divide it by 3. Now notice that this is a fraction. So I should make this a fraction. But dividing these fractions gets kind of weird. So we could always multiply the reciprocal or flip. So 7 times 3 is 21, because you always do top times top, bottom times bottom. So I have 21/4. That's how much time I should spend on each. Now, let's keep this going, because 21/4 to me doesn't look like a real number, right? So 21/4, top number special, it goes in the house. Bottom number is not, it goes on the outside. Can I put a 4 into a 2? Nope. Can I put a 4 into 21? Yeah, 5. All right. 4 goes into 10 twice. I got 5.2 hours. That doesn't make sense based on my answer. So 1 times 4 is 4 plus 3 is 7. So I have 7/4 hours to finish 3 homework assignments. So 7/4. So I guess I'm just doing my division wrong. But either way, B doesn't work. I'm going to go through each one of these in a second. And it's okay to make mistakes, but I'm going to figure out what each of these answers are as well. So B is out because it's got a mixed number in it. All right, so Samuel paid $3.20 for 1/4 pound of fudge. What is the cost per pound of the fudge? So we got $3.20 for a 1/4 pound of fudge. What is the cost per pound? All right, this one, they want division, but this is multiplication. If it's $3.20 for 1/4, $3.20 gives us 1/4. It's kind of like a ratio. How much is going to give us 1? So in order to do this, there's 2 ways we can do this. All right, let me just have more space here. So we have $3.20 per 0.25, and we want to know how much we can get for 1, and that's our x. This is one way to do it. I'll show you another way in a second. So x times 0.25 is 0.25x. 320 times 1 is going to be $3.20. We divide by 0.25. We divide by 0.25. X equals how much? When I have division with decimals, which is kind of annoying, right? 0.25. So in order to do this, and I'll show you a much easier way, we can move the decimal 2 places. So that allows me to move this 2 places. So decimals here. Whatever you move on one side, you have to move on the other. So I literally have 25 goes into 320. Does 25 go into 3? No. Does 25 go into 32? Yes, it goes in one time. Minus 32, or what is 12 minus 5? That is 70. 25 to 70. So 20, 50. So we have 12. That gives us 50. So I'm left with 220. So I have 12 point, because the decimal can't move, right? So we have the 12.25 goes into 200. How many quarters makes $2? Well, 25, 50, 75, $1. 25, 50, 75, $1. So it's 8. 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 25, 50, 75, $1 12.8. So that's the answer to C. It was multiplying really. So why is it really multiplying? Well, if I want to make this a 1, I could just multiply this by 4. So I can multiply 320 by 4. 4 times 0 is 0. 4 times 2 is 8. And we have 4 times 3, which is 12. Now notice I had how many decimals? I just basically pretended the decimal didn't exist, and then I count 1 place, 2 place, 1 place, 2 place. And we were left with what? 12.8, 12.8. So that was C. C is really a multiply problem, so I don't think it's C. Let's do D. All right, so Jacqueline has 2 bags of dog food. Okay. Here are my bags. Each bag holds 30.5 pounds. How much pounds all together? Okay, so this is adding, so it can't be D either. 30 plus 30 is 60. A half plus a half is a whole, so that's 61 pounds. Yay. So I'm going with A, right? I'm going with A. However, why wasn't it C? It was multiply. Why wasn't D? It was adding, but I didn't get the right answers for A and B, so I'm just going to do A and B again. But I'm going to go with A. So let's try A again. The simplest one, the one we should start with. So we have 3 children. See, we all make mistakes. We all get confused sometimes. And there are 3 children sharing 2 pizzas. To me, this is what pizzas look like. In order for each child to get the same amount, how much pizza can each one have? Now, there's 3, but there's 2 to go, right? So each one of these should get, I think it's 2/3 each. 2/3 plus 2/3 plus 2/3. Because there's 3 of them, 2 out of 3. This is what I'm thinking, right? Because it's just 2 pizzas for 3 kids. So we keep the denominator, we add the numerators. So that's how you add fractions. You always hold the denominator, add the numerator. So 2 plus 2 is 4, 4 plus 2 is 6. 6 divided by 3, there's our 2 pizzas. Okay, so that was A. Nothing too crazy about it. I'm sure there's a million ways to do it. So to create the fraction, I would do what? Well, I have 3 kids in total, and they're getting separated by what we're splitting up. So the splitting up is the numerator. So that's why it's 2/3 each. How do you check it? 2 plus 2 plus 2 is 6/3. So I think that's the answer. 2 divided by 3 is the answer, 2/3. So let's look at B, the one that I missed. So here's B. So Mario has 1 3/4 hours to finish 3 homework assignments. So I have 1 3/4 hours, which you multiply the bottom, you add the top. 1 3/4 is the same thing as having how many quarters? 4 plus 3 is 7/4. Okay, so we have 7/4 to finish 3 homework assignments. So we have, this is to finish 3 homework assignments. If he divides his time evenly, how much should he spend on each? So to me, I think it's 7/4 divided by 3. That's what I think you have to do. 7/4 divided by 3. So I'm going to try to do this another way. So 7/4, right? What is that really? Well, the top number special goes in the house. The other number's on the outside. Can I put a 4 into a 7? Yeah, 1 time. And 4 goes into 30. Well, 4 times 5 is 20. 4 times 6 is 24. 4 times 7 is 28. I bring down, because I have the dot, I'm allowed to put as many zeros as I want. And 4 goes into 25 times. So 1 3/4, or 7/4, is the same as 1.75. So I'm gonna do 1.75 divided by 3. I think I just flipped it the wrong way. So it's hard because I had a fraction and a division, which gets things kind of tricky. So which one goes in the house? The 1.75. Well, one's outside of the house, the 3. The decimal I have to leave where it is. Can I put a 3 into 1? No. Good. It should be less than 1 because we're breaking these 7 quarters into how many groups? Breaking 7 quarters into 3 groups. And I'll show you another way to visualize this. Okay, 3 goes into 17 how many times? 3 goes into 17. I'm going to go with 5 times. Because 3 times 5 is 15. And 3 goes into 25 8 times, because 3 times 8 is 24. And 3 goes, all right. I'm going to have 0.583 repeating, which is kind of crazy. So I'm going to just double check that with the calculator, make sure I did it right. 7 divided by 4 divided by 3. 0.583 repeating. Nice, I got it right. What's the other way to do it? Well, this was the way I was trying to do it, and let's see where the mistake was that I made. 7/4 divided by 3. So, oh, because I didn't multiply divided. Ugh, feel so stupid. Okay, so we can divide by literally multiplying by the reciprocal. So it's really 7/4 times 1/3. 7 times 1 is 7, and 4 times 3 is 12. All right, so all I have to do, time number specialist goes in the house. This number is over here. 12 goes into 7. It can't, so I put the decimal. 12 goes into 70. Is it 5 times? Yeah, that's 60. Nice. 12 goes into 100. I believe that's 8 times. Nice. So we got the same thing. 7/12 either way. And 12. Sorry. 7 divided by 12. 0.5833. Yes. So either way, we got the same answer. Sorry I had a little moment, but guess what? That's what happens when you do this stuff. You get confused. Well, let me make sure after all that it was A, because A was the easiest one to do. The other one had adding or subtraction. I think this is the easiest one to start with division. Let's see what it says. I don't want to go too far. I want to see the answers. So I can act like I'm you guys. Mathematics, the first one is A. Second one is A. Knowledge of division. The numbers used in the problems described are whole numbers. That's what I said. So the problem built on students' previous knowledge. 2 divided by 3 allows sharing for interpretation. The students will get 1/3 for each of the 2 pizzas, or 2/3 of a whole pizza. This shows that 2/3 and 2 divided by 3 represents 2/3. 2 divided by 3 represents 2 divided by 3. Sweet. I got it right. I like it, and I got the math right. All right, we did 10, 11. It's time for 12. Let's keep it going. See what 12 has in store for us. Here's 12. A math teacher is using 2 fair number cubes. So the first thing I'd have my students do is draw this. These are dice, but in math, they don't like using dice for gambling. This is how I have my students draw dice all the time. So we have everything here for us. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 1, 2, 2, 3. I try to have them make it look like the dice, so it makes sense for them. Here are my 2 dice. The teacher proposes an experiment in which both cubes are tossed and the sum. Okay, so sum is adding probabilities, okay? So which of the following determine a likely outcome of a 7? So how can we get a 7? So I can show you a lot more stuff with these dice. We'll do 7. I will do 7 or a 4. Okay. And I will do 7 and then a 4. Perfect. All right. So for probability, all you have to do is figure out what you want over the total. Well, how many total options do we have? We can have a 1 and a 1. That's 1. A 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. Or we could have a 2 and a 1, a 2 and a 2. These are all your options. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Then we'd have the same thing. 2, 1, 2, 2, and so on for all of them. So it's 6 times 6 more. So we know the total's got to be 36. How many ways can we make a 7? Well, I can go 1 and 6. I can go 2 and 5. I can go 3 and 4. I can go 4 and 3. I can go 5 and 2. I can go 6 and 1. These are all the possible choices to make a 7. I have 1, 2, 3, 4, 5, 6, which is 6 over 36 or 1/6. It's about 17%. If I were to divide this, I would get about 17%. I don't need to divide a fifth time for you guys. But oh, sorry. So notice that these are all the options. I'm going to erase these little circles so I can use them again. All right, so we know it's 1 and 6, 2 and 5, 3 and 4, 6 and 1, 5 and 2, 4 and 3. So that's 7. Sorry, that's 6 out of 36. So the correct answer is 1/6, or about 17% if you were to divide, or 0.166. Cool. So that's the answer. Now, let's say they wanted a 7 or a 4. So on probability, or is always adding and is multiplying. Now that might seem counterintuitive, but probabilities are always fractions. They're always these fractions. So to get them, we have to, adding them becomes bigger, easier to get. It's always easier to get a 7 or a 4. But if I have to do a 7 and a 4, if I have to roll a 7 and then roll a 4, suddenly it's much harder to do. So I need to multiply to make the probabilities smaller. So 7 or a 4. So we already have the 7, which is 6 over 36. Now, how many ways can I make the 4? I can go 1 and 3. I can go 2 and 2. Notice that I can't go 2 and 2 again because it's the same. So back and forth is the same, unlike the other ones. And then I can go 3 and 1. So there's only 3 out of 36 ways. So more space. So to do roll a 7 or a 4. A 7 is 1 and 6, 6 and 1, 2 and 5, 5 and 2, 3 and 4, 4 and 3. That's 6 out of 36. 4 is always going to be adding. 4 is just 1 and 3, 3 and 1, 2 and 2. Because notice you can't go back and forward. It's the same roll. So this is 3 out of 36. You add the tops. You keep the bottoms. You can divide it by 3. Oh, no, we divide it by 9. So what is the options for this one? To roll a 7 or a 4, it is a 1 out of 4 shots. Not bad, 25%. I divided top by 9. And I divided bottom by 9. That's how you can simplify your fractions, or 0.25s. So now we have to roll 7 and then a 4. So we already know the 7 is 6 out of 36. The bottom is 3 out of 36. Now, We could multiply top by top, bottom by bottom. However, since the numbers are going to get really big, we should simplify first. 6 out of 36 is really 1 out of 6. 3 out of 36 is really 1 out of 12. 1 times 1 is 1. 6 times 12 is, well, 6 times 2 is 12. Carry the 1. 6 times 1 is it's 1 out of 72. So these are three different probabilities right off the bat. I don't know what they asked us for, but I thought I would start there just to give you some more information. So let's see what they asked for. So which of the following must be known before all the factors for 7? That's what I did first. So I think 12's A. The weight in ounces of the cubes. Nope. Each of the possible outcomes of the experiment. This is all of them. This is the bottom. We do need that too. All the factors of the number 7 is not it. We want each of the possible outcomes because factors is not this. Factors are like what numbers multiply to make a 7. So that's just 1 and 7. But we need each of the possible outcomes of the experiment and the total number of outcomes of the experiment. So we need both of these. Each of the possible outcomes of the experiment and the total numbers of outcomes of the experiment. I must be known to determine the likelihood of an outcome of 7, each of the possible outcomes and the total number of outcomes. I think each of the possible outcomes of the experiment and the total number of outcomes, I think we need the total. I think that's what we need. I think we need D. I'm going with D for 12. This was hard. Let's see what they say for 12. 12 is D. Sweet. 3 for 3. The question tests your knowledge of the strategies for linking probability to the likelihood of an event will occur. Since probability is the total of desired outcomes, the bottom, over which we want, it's necessary to understand the total number so the probability can be calculated. Okay, B makes sense. Why isn't it C? Each of the possible outcomes doesn't really help us. So I could have all of these 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4. I could have all of them, but all we really need is the total. All we really need is 36. Each of them is every possible one, but do we have to write all these out in the formula? No, that's why 12 is B. Sweet, let's keep it going. Let's see what 13 has in store for us. Sure, I'll be getting some wrong at some point. Ben is having trouble multiplying 11 times 13. So 11 times 13. 3 times 1 is 3. 3 times 1 is 3. Then we have a 0 for a placeholder. 1 times 1 is 1. 1 times 1 is 1. Our correct answer is 143. Which of the following processes should be taught to Ben to help him evaluate the product? Finding the least common multiple of the two numbers. I don't think that helps us. When did these two numbers match? We'd have 11, we'd have 22, we'd have 33, we'd have 44, and the other one we'd have 13, 26, 39, etc. We would just see where they match. I don't like A. I think A is not going to be the best to help them out. B is the GCF. That also doesn't help us. The greatest common factor is just the factor they both share. The factors of 11 are just 1 and 11. They're both what's called prime numbers, which means the only factors are them in themselves. And 13 is 1 and 13. So they don't, their greatest common factor is 1. That does not help us. What's another factors? Let's say we had the factors of 8 and 12. Well, 8 could be 1 times 8, 2 times 4. This could be 1 times 12, 2 times 6, and 3 times 4. What is its greatest common factor? Where do they match? 4. 4 is their GCF. That doesn't help us. All right, C. Rewriting one factor of the product as the sum and applying the distributive factor. No. Okay, so rewriting one factor as sum and applying the All right, so what do they mean by this? We're writing, so for C, they're saying writing one factor. We're writing one factor of the product as a sum and applying the distributive property. They're saying if we took 13 and we changed it to be 10 plus 3, but then it's just 1 times it. 1 times 10 is 10. 1 times 13 is 13. Sorry. The factors of this are 1 and 13, right? So that's 1 and 12, right? So 1 times here, this is what C wants. I apologize. Some of them are really tricky. It's not, it can't be C, so it's got to be D. I mean, I hope. All right, so here's 13, right? I don't like this color. It's ugly. Sorry for those who like green. So they're saying if we take 1 and we do, because that's one factor, and then 13 is going to be 12 plus 1, because 12 plus 1 is 13. 1 times 12 is 12. 1 times 1 is 1. We add them together, we get 13. That doesn't help us to solve this problem. So what does D say? Rounding each number to the nearest 10 and then multiplying the two terms together. I think that's the easiest way. I'm going with D. I think that would help this kid out a lot. So instead of 11 times 13, we're gonna round this to the nearest 10th. So we're gonna tell this kid we're gonna do. So in 11, instead of this one, we're telling this kid we can do to the nearest 10th is 10 times 10. 0 times 0 is 0. 0 times 1 is 1. We have to hold the space. 1 times 0 is 0. 1 times 1 is 1. So we were left with 110. What's the closest answer to this? We had 143. So we rounded, we got 143. But if we showed the kid how to do 13 and get D, I think they'll be able to do it. So it's about making it easier for the student. So I'm going with 13 is D. 12. I want to not be able to see the other answers. 13 is C. Wow, okay. So I knew I was going to get one wrong eventually. So let's see what 13 has to say. It's really long. Okay, so option C is correct. This question tests your knowledge of strategies for understanding the properties of operations. The factor of 11 can be written of the sum of 10 and 1. I agree with that. And then the product of 11 and 13 can be found by distributing 13. Oh, okay. So they want us to break this down into 13 times 10. I just did it for one number instead of them both. 13 times 10 is 130 plus 13. And we're left with 143, the right answer. That does make it easier. It is C. Okay, that makes sense. Is easier and some, since one of the added is a multiple of 10, the student can do mental math to find the sum. Okay, I like it. I guess D didn't work because you still had to do the same steps. You still had to hold the place here. This is why D isn't right. I knew I'd miss one eventually. The place isn't right for it. But you're still basically doing the same process. I thought because the B1s and zeros would be easier, but they're saying if we actually break down 11 into 2 places, that'll be easier for students. Okay, not gonna argue with it. All right, let's go to 14. All right, 14. Let's see what we got. 14 is a geometry question. A 5th grade teacher has provided each student with a centimeter grid paper. Okay. Got our grid paper to explore how the 2-dimensional shapes can be folded into 3-dimensional shapes. So we're folding, let's say we're folding a square into a cube. Ta-da! Or folding a triangle into a triangular, either pyramid, which has a pointy top, or a triangular prism. So pyramid is a pointy top with triangles on the side, and this has like rectangles on the side. So the triangular prism looks like this, just so you can, either one you can make with the graph paper. Okay. Okay, are we rotating? So rotating is spinning. That is not right. Reflection is a fold or mirror. Reflection is a mirror. That's also not right. Nets, this is what it is. So a net is basically this. So the net is actually when it's all spaced out. Here's what the net of the triangular prism that I just drew. This is what's called its net. If I fold this up, I get the triangular prism. Another net, if you want to do a cylinder, it's going to be a circle with a circle, two circles, and a rectangle creates the cylinder. You fold it all up. The cube, just so I show you all of them, the cube is just 6 squares. Ta-da! All right, so that's the nets. And the last one's a tessellation. So tessellation is basically a repeating pattern like your bathroom tiles that like cover a whole space. So that's a repeating. This is why vocabulary is so important. I would suggest showing your students MC Escher. Some of his work is really nice. Here's a tessellation. This is called a sliding or a translated tessellation because each one of the fish birds creates the empty space. Does he have any other ones? He's just a great artist. Escher. There's other artists who do tessellations because they're pretty. And you can have students make their own. It's like a really cool here's the lizard one. Okay, so the lizard one is a rotated tessellation. See, it comes from a point and it spins all the way around. So all those lizards are spinning around. Cool, right? All right, let's get back into it. Oh, I should check it. So that's 14 is definitely C. I mean, I hope 14 is C. The question, test your knowledge of strategies for nets. Okay, ta-da. All right. Let's do 15. A teacher gives the students the following math problem. Riding on a school bus, there are 20 students in first grade, so 20 in first, 10 in second, 9 in third, 7 in fourth. Approximately what percent of the students on the bus are in first grade? So again, this is like a percent or a probability question. All you have to think about is what do they want over the total? And they say we get to round, which is nice, right? So what do we want? We want our first graders, which we know is 20. And we need our total, which is 20 plus 10, which is 20 plus 10 plus 9 plus 7. All right, so 9 plus 7 is 16, right? Carry the 1. 46. 16, carry the 1, 2, 3, 4, 46. 20 out of 46. And they want us to round. But basically, this is a division problem. So to do this, I would put the top number inside the house, the bottom number over here. 46 can't go into 20. 46 can go into 200, right? So It's not a quarter, right? This is too small. 26 is out. A quarter would be 10, like 13 out of 46. That would be A. And 73 would be 30 something, 35 out of 46. So already A and D are out. And you can teach your students how to do this process of elimination for their standardized tests. All right, so it's either 43 or 46. So we know the first number's got to be a 4. 4 times 6 is 24, carry the 2. 4 times 4 is 16, plus 2 is 18. So 184, let's subtract it. 1. So that's 16. 160. So we just have to see which one's going to be closer. I believe 46 times 6 is going to be too big. So let's see. Let's do the next number. Unless it's 45 in a little bit. So let's figure this out. Let's try 45. If it wants to erase for me, right? Sorry, my computer's working too hard with the video. I'll just move it over. Oh, here we go. So 46 times... We got 46. I believe it's going to be times 5. Well, let's find out together. 5 times 6 is 0, carry the 3. 5 times 4 is 20. Nope, it's too big. So it's got to be 43. Ta-da. 6 times 3 is 18, carry the 1. 4 times 3 is 12, plus 1 is 13, 138. It is going to be 0.43 or 43%. All right, so let's double check this, make sure 15 is right, make sure it's 43. Fifteen says B. Option B is correct. The question tests your knowledge of how to recognize misconceptions will occur and which strategy you use for reteaching. Percent refers to how many out of 100 or decimal forms, how many hundreds. To find the percent, divide 20 by the total of 46. This and round this number to the nearest hundredths place. This is 43 hundredths or 0.43%. Okay, cool. I'll take it. I want to make this bigger. I don't know what's going on. There we go. They said to find the percent, divide the number of students in first grade by 20. That's what I did. Okay, that was exactly what I did. Cool. What else we got? All right, so that's 15, which we got B, which was correct. Sweet. So I missed one so far. Maybe I'll miss another one. We'll see how it goes. So let's look at 16. We should be close to being finished. All right, 2 left. Okay, this one looks weird. The illustration above shows 4 students, Alicia, Bobby, Carlos, and Davila. All right, that's nice. A, B, C, and D. Use the blocks to not represent the number 32, which in a way that does not indicate understand. Okay, so base 10. So these are using number cubes. You'll see polygons, number blocks. One of the best ones to use is Polypad. I think this is really fun and helps people a lot. I've used Polypad a lot. Launched the Polypad. So they've got tanagrams, which are fun, where you can just make shapes, and it tells you all the vertices, which is nice and pretty. We've got polygons and shapes, and if you put them together, they like click on, which is kind of cool. You can turn them into a net, which is great. Deleting them is easy. So all this stuff is nice. So look what happens when I do, oops, if I put these all around the sides. I should be able to create the net. I'm gonna see if I can remember how to make the net. Let's do an easier shape. I'm gonna see if I can just make a. Oh, and you can just cut off pieces, which is really pretty. I'm just gonna make a 3D shape. Let's see if I can make one. Let's just start with the cube. See if I can fold this. I need 6 of them to make the cube. All right, I know I can copy and paste. We can put on a graph, which is really nice. Um, I think it's because I'm on the graph. Text block construction tools. Let's just make it circles. You can change colors. Well, I can't really find it, but basically they have blocks. I'm sure they have this one too. Pentagonal titles, the tanagram. Oh, here's the 3D solids. Oh, cool. Oh yeah, I knew we could unfold them. So it has to be on a separate form to unfold these things, but that's nice. But basically, if we have this, we just have to see which ones make a 32. Nothing crazy about that. So the first one, that's 10, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. She kind of ran out. She could have used 3, but that's okay. I think A works. A makes 32. I'm happy with it. Let's look at Carlos. 10, 20, 30, 31, 32. Carlos works. Bobby, 10, 20, 1, 2, 3. Bobby only made 23, so I guess Bobby doesn't know what he's doing because he thinks these are 10 and he thinks those are 1. So I think Bobby's the wrong guy. And this is 10, 11, 12. All right, let me count this one. So 2, 4, 6, 8, 10. So 10, 20, 30. Yeah, so everybody made 32 but Bobby. Usually it's just pick the one that doesn't belong. So 16 should be Bobby B. 16. Is it Bobby? It's B. He used 10 blocks. Yeah, he did it backwards. He made 23 instead of 32. All right, what's the last one? Okay. 4/16. What? Oh, 4/16 minus 1/8 is 3/8. That's wrong. 5/9 minus. Okay, these are all wrong. This is wrong math. The examples are shown to represent a pattern of student works if the error pattern indicated which would be likely. Oh, all right. So I got to find where this kid messed up. Our buddy, they don't even give us the name, but 17, find the error. Because 1/4 minus 1/8 is not 3/8. What did they do? 5 minus 1/2. They didn't make the same denominator. So they're not making the same denominator first. We know the denominator has to be 77. Do any of them have 77? Okay, so everything's wrong here. You have to find the mistake. What's the kid doing? I'll just take the first one. 4/16 minus 1/8. Big hat 3/8. So what did this kid do? The answer should be 4/16 minus 2/16 to get 2/16 or 1/8. So let's see the error of their ways. I don't know why it's not giving me another color. It's okay, it's the last one. Well, I want the right color. to see the change. All right. Oh, they just minus top and bottom. 4 minus 1 is 3, 16. Okay, let's see if they do the next one. 5 minus 1 is 4, 9, okay, 7 minus 1. Okay, this is it. So they didn't make the denominators the same. So 9/11 minus 1/7. So they're gonna get 8/4, which is 2. They got 2 as an answer, or 8/4. Oh, there's an answer C. So 17 should be C. Let's see if it is. 17 is C. Nice. The question tests your knowledge of how to recognize misconceptions. The student's pattern is subtract both. Okay, cool. All right, so that was one. How did you do? Well, how did I do? I missed one, right? So there was 1, 2, 3. So I think there was 8 problems. I did 7 out of 8. Not bad. See how you did? Well, what is 7 out of 8? Almost the whole pizza pie. This is how I see 7 out of 8. That's what I see when I see 7 out of 8s. Or you can do top number special, gets to live in the house. 8 goes into 70. 8 times, that's a 64. 8 goes into 60. 7 times, that's 56. So I got an 87%. Maybe I'll do better on the next one. I want to start with 2 practice tests for everybody to get started. I hope this was useful. No matter how you did, that's okay. It was just like a pre-test, go over, see how things work before we start the course. And let me know what you need help with, okay? Just really let me know how I can help you and what's going to be clear for you. And I hope you have yourself a great day. And I'll probably do the next pre-test and do some more today and then jump into the curriculum stuff. Take care.